Okay, today we're going to be solving polynomials with real and complex roots. So the first thing we want to do is, well, let's get a polynomial up here. We've got x to the fourth plus x to the third plus 5x squared minus x minus 6. So the first thing we want to do is figure out what the possible real roots are. So we'll take care of the real roots first. So factors of 6 over factors of 1, we'll get plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Okay, so now that we've got that, let's try some of these. We're going to take the coefficients, and the coefficients are going to be 1, 1, 5, -1, -6, and we're going to try, well, let's start with 1. We'll start with 1, see if that works. Bring down the 1. 1 times 1 is 1. 1 plus 1 is 2. Multiply, you get 2, 7. Multiply, you get 7. This becomes 6. Multiply, and you get 6. Hey, all right. So the remainder is 0. So that means 1 is a solution. Okay. So now we've still got all the rest of these as possible solutions. So we'll use this. We'll use this set of coefficients here. Let's get rid of that. So we're going to use this set of coefficients, and we're going to, let's go with -1. So we'll go with -1 and see if that satisfies this. So -1 times 1 is -1. 2 minus 1 is, so we got -1 here. This is 6. We go -6. Oh, geez, that's great. So we get another 0. So -1 is a solution. So now what we've got is we've got this down to a quadratic. So this will be x squared plus x plus 6 is the quadratic we're working with. So remember, once we get to a quadratic, we either factor or use the quadratic formula. So in this case, well, I can't really factor this because two numbers that multiply to give us 6 but add up to 1 can't happen. So we're forced to use the quadratic formula. So remember the quadratic formula, -b plus or minus the square root of b squared minus 4ac all over 2a. And I'm sure you sung that to yourself as we were going through it. So b, -b, so that's -1 plus or minus the square root, b squared is 1, minus 4 times 1 times 6. Well, this tells me in the what's called the discriminant, which is right here, this is 1 minus 24. Well, that tells me I'm going to have a complex solution. So let me finish this up here. So this 2a is 2. So now if I do the math out here, which is why we're here, is to do the math, we get negative 1 plus or minus the square root of negative 23 all over 2. And I can change this to turn it into a complex number because I know that negative 23, well, the square root of negative 23 is I times the square root of 23. So I'm going to change this around a little bit, and I'm going to, first of all, I'm going to separate these into two different fractions, and I'll pull the I out. So I times the square root of 23 over 2. Now, I would much rather see this out here, because remember, it's a plus or minus b times I. So to make this a true, like, standard format complex number, we're going to change this to be negative 1/2 plus or minus the square root of 23 over 2 times I. And there's our complex number. Now, what are our solutions? Well, if we go back to the beginning, we see we have 1 and negative 1 up here, and then the complex number. So we've got 4 solutions, which is good because this was a 4th degree polynomial. The solutions are 1, negative 1, and then the complex numbers. And that's our solution set. Okay? So let's do another problem. Okay, so here's our second problem. We're going to go with x to the 4th minus 5x squared minus 36. Find all the zeros. Okay, so a couple of things to be aware of. We're skipping exponents here, so there are going to be some zeros when we do synthetic division. So what are possible real zeros? Or rational zeros. So we got plus or minus 1, plus or minus 2. Remind ourselves this is the factors of 36 over the factors of 1. Oh, that's not plus or minus 36. I was saying that, and I should have been writing plus or minus 3. So plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. Now that is an awful lot of potential real zeros. So we're going to start, probably going to start with the positives, work our way up from 1. I've already done this, done this problem. So I know that positive 1, positive 2 don't work. Let's try positive 3. Now, when we're setting up our synthetic division, because we've skipped terms with certain exponents, we have to put a placeholder there in our synthetic division. So put a 0 in that space. So this is x to the 4th plus 0x to the 3rd minus 5x squared plus 0x, and then minus 36. Okay, now we'll run through our synthetic division again. There's 9, that's 4, that's 12, and then we get 36. Okay, so we got a remainder of 0. That means 3 is a real 0. Now, like I said before, I've done this, so we shortcutted some of the work. Um, I'm going to go with -3 this time around, just to get these real zeros out of the way, so we can get down to a quadratic. 1, 0, -5, 0, and -36. So we go 1, -3, -3, -9. Oh, sorry, that's +9. There's 4, there's -12, -12, +36, which comes out to be 0. So -3 works. And that was not the way I wanted to do it. But -3 works. Now, I made a mistake here, and I'm going to correct that. We know -3 is a 0, but I wanted to get it down to a quadratic. And what I should have done was I should have used 1, 3, 4, and 12 as my coefficients. They come from up here. So I'll go back through because I want to make sure that I end up with a quadratic. So -3, that's 0, 4, and we get -12, which is 0. Okay, so now we've got a quadratic left where we've got x squared plus 4, right? X squared plus 0x plus 4. Well, in this case, we know x squared plus 4 equals 0. Well, x squared is going to be -4. So we take the square root of both sides, and we get x equals plus or minus the square root of -4, which is plus or minus 2i. So my solutions are 3, -3, and plus or minus 2i. Okay, I hope this helps you. Try the homework on your own, and be sure to drop me a message if you need extra help. Okay, or you can we can get together on the Zoom meeting. All right. Thank you very much.